Hey everyone, so welcome back. If you haven't watched the first part of this video, please, I do recommend you watching the first part. I will link it somewhere up in this video. It's really important if you don't know what gRPC protocol buffers are. What's the point of this video? So I really recommend you watch that. But for everyone else, stay tuned and I hope you enjoy. Alright, so if you remember from last video, we went through the definition of what protocol buffers are, what gRPC is, and what we're going to do to try to learn all this stuff. So the place we left off is we made our server, and now we started it, and everything works fine. The server loads up perfectly well. Now what we need to do is we need to create our client. So someone needs to talk to our server, right? So let's create that right now. Now, I'm not a silly programmer. I'm not going to show how smart I am by coding it again when I know that all this stuff is repeated. So I'm just going to copy this and just paste it right over here. So if you know from your last code all the way up to your random package, all the way up to the very top, and paste that over here. We actually will not use handlers because handlers is something that is defined only by the client. If you've been a backend engineer for some time, you know that handlers is specifically only client related. So we're going to remove that. We're going to need the port. The port's going to be important. We're going to need the package definition. We're going to need the gRPC object. And then we have the package definition, and we load the package definition, and we have the gRPC object, and then we get our client. Okay, so we take this, we take our gRPC object, our random package, and then we dot random. So that's the entire name of the package, and then we pass in the host name where the server is. So the server is on port 0.0.0.0.0 colon and then our port number over here. So it's port 80822 comma, and then we do need to server credentials .create insecure. So we need to create an insecure connection over here because it's our local development. It's nothing too important. Also, one thing I need to do is initialize this. So new, and then over here it's gRPC credentials.create insecure. And this now is going to be our client. So this is going to be our client that we're going to be using to communicate with our gRPC server. So let's do a couple things. Let's not let the client time out for any reason. So what we're going to do is we're going to create a deadline, and all this deadline is just a date object. It's just a JavaScript date object. And then over here we're going to do deadline dot set seconds, and we're going to say deadline dot get seconds, and we're just going to add 5 seconds to it. So we're going to take that, and then we're going to say client dot wait for the deadline, and then there's just going to be a callback function. Look at the beautiful, just the elegance of TypeScript. We're getting all of this at the top over here, so we know exactly what we're doing. Right? We're not complaining about oh, Golang is better or Java is better. They have TypeScript. You have TypeScript right here now. Anyways, so we have our arrow over here, and we can just say if error, then we want to just console log, or not console log, console error the error, and we just want to return. Okay, great. So now what we're going to do is, so this is the callback function for when the client is ready. So as soon as the client is ready, we want to make communication with the server. So we're not going to put all our functions out over here. We're actually going to put it inside our callback function. So when the client has made the communication successfully, then we want to do it. So we're just going to make a function here called, on client ready. Right, we're going to make on client ready, and over here it's just going to be a function called on client ready. So now, I mean, client is a global object. Okay, so I was gonna inject client in here, but client's a global object and that's overkill. So I'm just gonna access it from over here. So now welcome to the land of gRPC. You don't have to use fetch and point to a name. You can just do dot ping. Oh look, ping pong is right over here. So you just do ping pong. And over here it takes in the arguments. So the arguments, if you remember, was a message, and I'm going to say ping, right? And I'm gonna put a comma over here, and it's going to take in a callback as a second object, so, as the second argument. So it's going to be a callback with an error and a result. That's how Typescript's defining it at the top. So I'm just going to say if error, I'm just going to handle all my errors over here, and just say console.error, error, and I'm just going to return over here. And then for the result, I'm just going to console log the result, right? Console log result dot message. No, that's overkill. I'll just console log the result. So now if I run this, it's just going to execute this. Okay, so everything looks good over here. I think we're ready, right? We're ready to make our first gRPC call. Okay, so let's go to our server and start our server. Then we'll create another terminal window over here. So our server is up on port 8082. So now we'll go over here and say yarn start client. And let's see what happens. Bibbidi bang. No address. No address added to total one result. Oh, okay. Yarn client. Silly me. Okay. Anyway, so we started up our client. Let's make this a little bit bigger, and this might be taking some time because this is TypeScript, but it shouldn't be taking this long. Put a timeout for 5 seconds over here. Let's go to our thing over here. Okay, so we did get something. So we go back to our server over here. Let me actually split screen this so we aren't, that might actually make things more confusing for everyone. But I'll bring it back here. All right, so let me close this, go to our server over here, and let's go to our ping pong request over here. So it seems like we console logged our request and result. So we did receive something. The reason why we didn't see anything in the client is because we didn't respond appropriately. So what we're going to do is just say respond, and it's actually a function where it takes whether there was an error with the request. So in this case, I'm going to say null, and then it's going to take the defined body that we declared. So it's a message, and we're just going to say pong over here. Pong, and let me remove res. We don't need that, and we just say request dot request dot that's enough. Request dot request. Let me save that, close this, start this again, and let me go back to the client. Let's go back to the client. So your server started on things. So now if I go over here on my client, run that, and we see that we did get a message from our server over here with the message pong, and we sent a. Now if we go to our server, we got a request saying ping. So this is a regular sort of the closest thing to a REST call, where you send a payload once, you get a payload back, and that ends the sort of transaction between the client and the server. So now let's move on to server streaming. And I picked server streaming because I think that's much more real life. I think servers stream more than clients. Very few. Depends on what you do. Actually, don't. I'm gonna stop talking and just code. Okay. So on client ready over here. So now I'll make another call. Actually, I can't even make another call yet. What I need to do is go to our proto file and create this server streaming service. So what I'm going to do is I'm going to create an RPC service called random number generator. I'll just call it random numbers. Okay. What it's going to take is a number request, and it returns a number response. Okay, plain and simple, pretty easy. Now all we have to do now is define these messages. So message number request, and this is going to be the, I want to take in an int value. Let's make this int32, an int32 value of what is the max number do I want to receive. So the client's going to be like, hey, I'll send you 100. 100 is the maximum number I want my random numbers to be. So it'll be max, let's call this max val. Max val is equal to 1. Okay. Within a message, it would have sequential numbers for their different parameters. So number request, and then number response, and it's going to be an int32 of just val. Let's just call it num, right? Num. All right. So now we go back over here. Let's close our server and let's do our yarn proto-gen. We made that helper function, so this should be good. Creates some ping pong request, number request over here, so we know we're good. Also, if we go back over here to our random number handlers, we can just do, now you notice we have IntelliSense for our random number service. How cool is that? So random number, and it's going to pass you a call object. So this is something different between our unary request. So if you notice, it passes you now only one argument. So we can only take one argument over here. So call that and that. So call is a really neat thing. So what we can do is we can write data onto this call object. So call dot, what was it? Call dot, where did I attach the, oh wait, I forgot. Yes. What I need to do is say who is streaming what data. So in this case, the server is streaming the data. So I got to put stream at the inside the argument over here. Actually, let me double check before I bite my tongue on that. Yeah, no, it makes more sense for the response to be streamed. So the response over here is actually streamed. My bad. So the response is streamed, and it makes sense, right? The response, we're streaming the response. It's not the request that's getting streamed. So now let me generate my proto once more. Make sure I have the right definitions, and then let me save this. Let me rewrite this. Random, and it's again going to be a call, right? And over here I can do call dot write. Okay, this is cool. And we're gonna write our chunk. They name it chunk, but it's just a number response. So what we're gonna do is call, and it's gonna take a number. And what I'm gonna do is math.random. Actually, I'll do gotta wrap it in a math.floor, math.random. And it's going to be our max value. So, but where is our max value, right? So we have to do call dot request dot max val. So this is where the client will send a max val variable, and this is how I can read it. So I'll just say const, and I'll actually just destructure it over here. And it's just going to be max val, max val. It's just pooping itself because I don't have the proper definitions. Okay, so now I can do max val over here, and everything is good. So if you notice now, one thing we have to do now is that the server has an open connection with the client. And so now as the server, you need to tell the client when you're done sending data. So after you write your data, you want to do call.end, and this will end the communication with the client. And let's see if this takes anything. Let's see if TypeScript help us out. And it's void, so it's fine. It's just void. So now let's go to our client, and we can do the same thing again. We can do client dot random numbers, and what's going to take? It's going to take an argument list of our max val. Okay, so our max value we want to go up to random numbers is going to be 85. So what's this going to give us? It's going to give us a stream variable. It's going to give us a stream variable. So with that stream variable, you can do on every time. It's almost like it's an event listener. So an event listener for data. So whenever we get data, we are going to get we're just going to get a chunk, I believe. And this is not typed. I had this problem before, but we can fix this problem because this is actually data that we get from our data that we get from our server. So let's just console log the data over here. Sorry, the chunk, right? And at the bottom, we also can listen. So stream.on end, we can listen to the end event for when the server stops the communication. So we're just going to say console.log communication ended, right? So now we have all of this fun stuff over here. What we're going to do is we're just going to comment this out. We actually just don't want this to get we don't want this to run, so we're just going to comment this out. So now let's go to our server and let's start this up. So yarn start over here. And things break because this could be possibly undefined. So what we're going to do is use JavaScript's quirks and say max value, and if there's nothing, I want to default it to actually not 0 because we won't get random values. We make it 10. Okay, now we run this, yarn start, everything works perfectly. So now we go over here and yarn hit the client, and we notice that we got a number that is 12. Ooh, and we also have the communications ended. Let's go to our client. We actually didn't console log anything over here, but okay, let's just do this over here. Console log max value, just to see the max value that we're getting, because this is pretty much, yeah, it says 85. Let's see if we're getting 85, right? So go over here, hit up, and random number we get is 18, and the server receives, oh yeah, I need to restart the server, silly me. Server started, run this again, random number I get is 84, very close to my max, and we see the max value is 85. But this is not really demonstrating the power of streaming. So what we're going to do is we're going to make a set interval over here. So set interval, right? It's going to take a callback function, and I just want this to run every 500 milliseconds. And I want this to run, so let run count is equal to 0, and then I'm going to say run count is equal to run count plus run count, right? We want to just increment it by 1. And if run count is greater than 10, or let's say greater than or equal to 10, we want to stop this interval, the set interval. So what we're going to do is we are going to clear interval, right? I'm not sure if how well everyone knows JavaScript. If you really want to know about JavaScript, I'll attach some card somewhere over here where you can watch how JavaScript works and why we need to do this. I won't really get into this too much because I've gone over this in other videos. So clear interval, we're clearing the interval, and then we will also call .end. Over here, we're just going to end the call, and we're just going to bring this up over here, and let me clean this up a little bit. So now let's see what's happening, right? Let's see in our code what's happening. So we're getting our max value, we're console logging it just to make sure, and then we have a run count that's initialized to 0. So now what happens is we are going to start our set interval. We're going to run it about 10 times, and we're going to run it every 500 milliseconds. So fairly quick. It should get done in 5 seconds. So let's restart this server right now. All right, let's restart the server, and let's hit this server with our client. Let's see what we get. 29, 21, 32, 54, and it's done. The communication's ended. So let's go back over here, and you notice we're seeing the same thing. We're seeing max value is 85, and we got a stream of data from our server, and we ended the communication over here. This is really cool. This is actually what I had a lot of fun with. So yeah, that's pretty much like the power and how you can leverage server streaming, right? So now let's move on. Let's do client streaming, okay? And for client streaming, I think this is pretty useful. So RPC to-do list, right? So the client's just gonna store this data, and the server is just gonna store the to-do list data, and the client's gonna send it in streams. So it's going to be a to-do request, and it's going to be a stream. Let's not forget, this is very key to tell gRPC how to handle this service. And then it's going to return a to-do response. This doesn't matter too much because it's just one response, right? And then at the end it's going to be an empty object. And let's go down over here. So message, let's define our to-do request, right? What is our to-do request? So it's going to be a string of to-do, right? This is equal to 1, and then it's going to be a string of status, right? It's going to be like, is it pending, is it started, is it completed, something like that. We'll set that to 2 as well, and really that's about it. And then we're just going to have a to-do, oh, I think I like this, message to-do response, and what we're going to send is actually repeated to-do request. Ooh, boy, what did I do here? So I'm going to try to send back, client's going to send a bunch of to-do requests. It's going to be like, I'm going to need to do laundry, I need to do grocery shopping, I need to walk the dog, walk the wife, I don't know, so he's going to put in all those to-dos, and then the client's going to get back the chunk of to-dos. So let's do that. First and foremost, don't forget to generate your TypeScript definitions. So we go over here and just do yarn proto gen. So it's going to generate your proto definition, so you have everything up and ready for you. All right, so now we can go over here and we can this is what I wonder whether let's see if I get any errors from the thing over here. It doesn't seem, oh, I think I got some errors. I think I got something wrong. So to-do response, there's one over there. To-do request, got one over there, one over there. Just making sure. Oh, returns. Okay. Okay, yeah, so it's repeated to-do request, which is going to be the type, and then it's going to just be the data, right? That's going to be the thing that holds it. Actually, to-dos is a more appropriate word. All right, so now we can run this, and now we get successful compiling, and now we can go to our client over here and just say, should get TypeScript definitions now. There you go, to-do list, woo! All right, so it's going to take a call object, and inside this call object, so this is client-side streaming. So it's going to take a call, and inside this call, again, I can destructure the data. So equals to call.request. Okay, so it's going to take a call and a call back. So if we call back over here and we hover over it, it tells us that it sends a unary data. So it's like sends it once and that's it, right? That's exactly what the server is allowed to do, but the client's just allowed to keep sending. So what we're going to do is whenever the client sends data, so call.on data, we are going to get an object. We're going to get a function that passes us a chunk, right? It's going to pass us a chunk of data. So now this was, I think, the problem I was getting. Let's see. So if I console log the chunk dot, yeah, so let's figure this out soon. So we'll do that, and then when it ends, so we're just going to append on this. So let me actually make a to-do list over here. So const to-do list is equal to an array, and we're just going to add on to that. So to-do list push the chunk, and then when the client decides when he wants to stop the communication, so it's going to be call.on end, and it's just going to take a callback function. And what we're going to do over here is we are going to send back our to-do. So it's going to be, the first argument is going to be null, which we're going to say is no error. And then this is going to be an object of to-dos, and it's going to be our to-do list over here. Perfect. So this looks really, 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 really good. All right, so now let's go to our client and let's create this communication, right? So go to our client. So let me comment this out over here, and let's create our client. So const stream is equal to client.to-do-list, and over here we're just gonna take an error. It's just gonna be a callback function error, and our result over here. So error and result. And over here we're just going to console if error, and console log the error. Otherwise, we just want to console log the result. Cool? That looks cool. And we're just going to return over here just so we don't make any funky stuff. So now over here we can do stream dot write. We can write to the stream our to-do list. So let's make a bunch of random to-do list items over here. So we need to do walk the wife. It's getting really misogynistic. Walk the wife, and the status is never, because I'm not a horrible person. I don't do that. Okay, so we want to write this, and we want to write a bunch of these, right? So we're just going to make a bunch of these. Make about 4 of them, and this one is walk the dog, get a real job, feed the dog, right? So walk the dog, doing, get a real job, impossible, and then feed the dog, done, right? So now we're going to write all these, and then at the very end we're going to stream dot end. We're going to end the communication to the server. We're going to be like, hey server, we're done talking, I don't like you anymore, me and you aren't friends anymore. Okay, so now let's go back to our server, restart this, make sure everything is good. So to-do list is probably, because it's an empty thing, so we need to typecast this obviously as a to-do response. Okay, so to-do response is actually an object where the data is an array, right? So let's actually data undefined is not known as a thing. Say as to do request. That doesn't make anything better. How do we typecast? Let's go to the definition. So it's it's thing of to-dos. Okay, so it's just to-dos, just an array. There you go. Okay, cool. So now our to-do list, we're just going to-do list dot to-dos. We're gonna push that onto there, and then we're just gonna take this and put it in there. Cool. I think that's fair, right? Let's yarn start and see what we get. We got some errors, possibly undefined. Okay, so we can short circuit this over here, and that should be enough, really. Short circuiting it, yeah. Okay, that is enough. So now we can go to our client and just do yarn client over here. Okay, see what we get. Okay, look at that. Look at that. All right. So let's see what happened to our server. I didn't put any console log. I don't think I did. Oh, I did. Yeah. So for each chunk I got a message from the client. So I got 4, right? Walk the wife, walk the dog, get a real job, and feed the dog, which is really cool. And guess what? This server is sort of stateful. I mean, this data is stateful. So if I send a request again, over here, I should get 8. Yeah, so I get this repeated again because I sent it again, and I'm here at the server and I got another 4 of them. And look at this now. So I'm writing about 4 of them. So I initialize the to-do list and I have a callback function saying, hey, I want to listen to any errors or any or the result when it's done. And then I'm going to get a stream object from it. From the stream object, I can write data to the stream. And over here in my to-do list handler, I am going to listen to the data event, and I'm just going to push the data onto the chunk onto the thing, and then it should be good. So yeah, this is annoying because this is happening. So I need to do to do request. I think that's appropriate because now if we do chunk dot, yeah, so this is good. Okay, so that's an accurate representation of what's going on. Sometimes the type inference doesn't work all the time. It's best to not infer any types, but you know, it is what it is. Okay, so that's it for this. So we've done unary calls, we've done server streaming, we've done client streaming, and we're gonna take a little break from this video and we're gonna come back and finally make our bidirectional streaming in a chat application sort of manner. And we're going to make multiple clients talking to each other on the same chat server. So I hope everyone enjoyed this video as much as I did, dude. If you did enjoy this video, please drop a like, show some love in the comments section, and I will see you in the next video. Peace.